And welcome back. Now today is the results of the ATTiny13 down here buried amongst this breadboard fridge door alarm challenge. Now if you remember a few weeks ago I said, can I convert my fridge door alarm that I have running for years now, but it uses an AT-Mega328P. In fact, it uses a Nano, a plug-in Nano. So I plug the Nano into a bit of strip board, all the surrounding components. The circuit is simplicity itself. You've got a reed switch by the door. So as the door shuts and closes, there's a little tiny magnet on the door, and that opens and shuts the reed switch. That's fine. It's got a little beeper inside. Oh yes, and it's also got a single touch switch. So it's a touch pad, in fact. Single wire touch pad. You can do it on the Arduino. There's a library for it, capacitive touch sensor. And you can just touch that. A little LED comes on, and then when you open and shut the door, you don't get any noise. The little door opening and closing sound, because Benny, the little terror, has recognized that sound and goes, woohoo, what's he getting out of the fridge, right? So sometimes it's better to just press that, open the door quietly, get the milk out, and make your cup of tea without him rushing out. So that was the fundamental basis of which I started this challenge, to say, was the ATTiny13 just a useless, rubbish, brain-dead chip, or can we actually do something useful with it? And today we're just going to have a very quick summary, I think, of how far I got with it. Can I replicate all the functionality in that little tiny 1024 bytes, yeah, count them, 1024 bytes of flash memory and 64 bytes, I know, 64 bytes of SRAM, that's for all your variables and stuff, yeah, can I actually create it in here? Well, the obvious answer is pretty much, okay? I've had to make some serious compromises, but actually, if we're going to measure, you know, apples and oranges together, which is sort of always a bad idea, but you go, is this functionality on this breadboard here right now, is it pretty much the same functionality as I've got? And the answer has got to be, yes, it is. It is pretty much. There's a couple of compromises that I'll go through just very quickly, but let's plow on. Right now, I'm using on here, you can just see it behind my head there, that little tiny ATTiny XX 85 really, but I've got a 13 on there actually. ICSP programming board. That's this little one here, look. So I've got a surface mount ATTiny13 in there. So I've got dual sets of pins and the ISP and a reset. And that plugs into the breadboard rather nicely, so that I've duplicated the pins, you know, spaced out, and that makes life a lot easier. I'll show you a close-up of this when we've had a little play, because otherwise if I touch something it's all going to go wrong, isn't it? So let's just move things out of the way a little bit. I haven't got this plugged in because I haven't got the power to this switched on with a USB cable, and what we're trying to do, what happens then is the power from here goes up the wire and starts powering this thing as well, which is not what it was designed for. So we'll just play about with this. So this is effectively my fridge door alarm. There's the little piezo sounder. There's an LED there to show me when the door is open and shut. Let me bring in the serial monitor. This is CoolTerm. I've mentioned it before. Absolutely brilliant product. It just monitors the serial outputs. Very forgiving. You can set the thing to ignore errors and whatnot. So yeah, I'll put a link down below. Actually, it's freeware. You can donate if you like it. Yes, I have. I couldn't possibly show you guys without giving him a few quid, could I? So yeah, have a look at that. Let's bring that up next. Okay, so I've put it a little bit off screen there because we only need to see the first few things. Now the first thing you'll see there is that the word go is displayed. Why is that a big deal? Well, I'm using the microcore for this, which we've been through before. MCU Dude and Nerd Ralph had a hand in that as well. We went through that in that previous video. I'll put a link up where we've talked about all this. So microcore is what I'm using on the ATTiny13. Very good, keeps a really compact set of code coming out of that compiler. And one of the good things that I've managed to get working is the hardware serial. It's half duplex serial, and it works fine, although I've had to make a few tweaks to get it to work because I wasn't having much joy yesterday, and I can only get it to work on 1.2 megahertz. So this is running internally on 1.2 megahertz, which is no big deal for me. You don't need a Cray computer to monitor a fridge door alarm, believe me. Okay, so when we reboot, you get this OK, no, not OK, go come up, and I've emulated the door switch just with this little DuPont wire to ground. So normally the door will be shut, so we're on ground. And when I open it, so that it breaks the switch, and I haven't connected up the serial monitor. So let's do that first. God, I tell you, it's shambles here. Okay, connected up. Let's try it again. Right, there we are. Door's open, okay? And you heard the sound. And I'll shut the door. Oh. Right, the door's shut. I hope you can hear the sound as well. That was from Lucas. Remember I mentioned his library. I'll put a link to his website. Oh, that's his full name. He was impressed. I think that was slightly tongue-in-cheek at my pronunciation of his surname. I'll try and do better if I ever have to say it again. Okay, but anyway, Lucas's website is absolutely brilliant. It's got 100 projects just for the ATTiny13 alone, plus loads and loads and loads of other stuff. So please do go and have a look. It's great that we've got people like that who are devoting their time developing all this stuff for people like me then to consume and show you guys. So yeah. Okay, so what else can I show you about this? Well, if we open the door and leave it open, then obviously after a minute we get a reminder beep. Now this is subtly different to the one I've got at the moment. The one that's operating, it beeps after 30 seconds and every 30 seconds. And the number of beeps go up as well, so you get 1 beep, then 2 beeps, then 3 beeps and so on. Exactly the same as I've got on here. So that works. I'll show you the beeping later, but I want to move on really. The other thing that I've had to make a compromise on then, this touch sensor that I've got on my Nano at the moment, okay? You just touch it, a little light comes on, and it stops the sound. Okay, well, could I put that on here? Absolutely not. That capacitive sensor for the Arduino took up about 1K of code all by itself. It's ridiculous. I thought, what have I done? What have I suddenly introduced here? That capacitive touch sensor, no way. So I thought, all right, if I can't do that, that's a bit of a deal breaker really, because I want that functionality. That really was important. Okay, so I thought, in my Home Alone project, I've used the TP223 touch sensor, and brilliant. It works every time. It's been working in my mum's flat in Stuttgart for months and months and months and months, and it's great. And it's a touch sensor, so you don't actually have to physically press something. You just go near it, and it's self-calibrating. So if you've got it, as I have, for the Home Alone one, it's underneath the Perspex case, and on top of that there's a nice large washer. Well, not a washer, it's actually a cat emblem like you have for, around their necks, but it's very big, just to give it something to look at really, and it looks nice, rather than a washer, which is what I used in the prototyping. So when it switches on, it calibrates what it can see and detect, and that washer is all taken into account. So when you then approach it and touch that, it goes, now there is a difference, and I'll take into account the fact there's this massive lump of metal above me first, and it works like a dream. So that's what I've actually fixed up here. Now you can see that red light on there. That red light should not be on. It's because I've modified this one, because there are various states you can put this one into. You can have it like high output, low output, toggle output, with the light or without. There's a number of different things. I'll put a link into the datasheet for that as well, because it's a very, very cheap way of getting a touch sensor. In fact, if I'd known about this when I did my Nano fridge door alarm, I probably would have used this in preference. Actually, it's just so much simpler. Anyway, if I touch this now, or approach it even, so I touch that, what's that blue one over here? Right, so you saw the red light go out as I approached it. The blue one is now lit. Doesn't look very blue, does it? So now if I open the door, so this thing here, you see the door open on the serial monitor there, blue light still on, and I close the door, blue light goes off. So that was the silent door opening and closing. Do it again, of course it's going to make the sound. I realise I'm a bit cack-handed putting this in here, but yeah, okay. Right, so that bit's working as well. Now, could I retrofit this into the existing housing I've got and everything, bearing in mind that my read relay is in fact inside a little tiny bit of what you use for burglar alarm trunking, and it's reasonably neat, has to be, obviously the boss indoors. No, I don't mean Benny, I mean the real boss. The CEO of the house would not accept anything that looked out of place, believe me. So this is white, a little bit of trunking, all cut to size, hidden in there. You don't really see any wires because the wire comes across the top of the fridge. It's a tall fridge, fridge at the top, freezer at the bottom. So you don't see the wire coming across the top, and it just drops down immediately into this little white thing. But The capacitive sensor only needs one wire, which is also self-calibrating, by the way. And it calibrates every few seconds as well. I think I've got mine set down 10 seconds. But it only needs one wire. So let's think about how many wires I've got going to that little bit of trunking. I've got the read relay plus ground, obviously. I've got an LED output which uses the ground, and I've got the capacitive touch sensor wire. So that's 4 wires I've got. But luckily, I'm pretty sure I've used some UK British Telecom wiring for that. So I think it's got 5 wires on it. So if I did want to use this, I could, to have the signal back again plus the power to it. It needs power, obviously. So I could theoretically use that touch switch even now, you know, retrofit it. So that's good. So the functionality is equivalent. Let's have a very quick look at the code then. And while we're looking at the code, I'm going to open the fridge door so you'll hear the alarms going off, you know, over a period of time. Right, door's open, and you know, I've left it open because I've got the milk out and didn't shut the door properly. Right, let's have a look at the code while that is running. Oh, I think we'll take off that monitor. Oh no, we'll leave the monitor on because it actually tells us then when there's an alarm. So, skimming through this code, let's start at the top, shall we? After this very important message from my sponsor this week. I'd like to give a big shout out to my sponsor PCBWay, PCB Prototype the Easy Way. Let's have a look at their new Superior A+ Advanced PCB. Here you can find all the details of what their advanced PCB service consists of, and there's a handy comparison table to see the benefits of the advanced PCB service. Scroll down to the PCB showcase and you can see some examples of what they can do for you. Just go to their easy online PCB instant quote page and select the advanced PCB option. Simple. If you have advanced requirements for your PCB, try PCBWay. Try them now. And we're back. Right, now this is the code then. So I've described at the top here all the pins, both the PB numbers and the physical pin numbers. And on that little PCB that I'm using here, if I bring that into... oh. I'll have to go back to the workbench. Here we are. So on here, if you notice, oh, alarm. Did you see that? Warn, it says warn. The first warn, on that serial monitor, if you look over there, the first warn that came up was in fact silent. That's the way I've done the code deliberately. So we've got a whole minute of silence, because one of the things that irritates my wife a little bit is that it beeps after 30 seconds, which isn't a long time at all. In fact, when I get Benny's medication out every day, I mean, it's all a slick operation these days. You know, there's a little syringe in there we have to put it into. But even then, that 30 seconds is a bit short. That double beep you heard there was the second audible warn. Anyway, back to this. You can see I've put the PB numbers on the top one there. And the physical pin numbers down the side of both, in case we are using both sets of pin headers. And that is really useful to keep the two in mind, because sometimes in the code you need pin numbers and sometimes you need PB numbers. So yeah, just something to bear in mind. Right, back to the code. Oh, third time. Right, so let's scroll down this quickly. Obviously there's lots of stuff, you know, defined at the top. You notice I've commented out the capacitive touch sensor. I cannot use that at all. All this is just defining stuff. There's nothing particularly interesting about all that. This is a forward declaration of all the routines that I've written, all the functions that I've written. I have to do that because I'm using Eclipse here, not the Arduino IDE. But funnily enough, I kept copying the code en masse into the Arduino IDE to give me a better sense of how much space there was, because the Arduino IDE is a little bit more friendly in telling you exactly how many bytes you've used compared to the Eclipse. The Eclipse does it as well, but you have to interpret it more. We'll do it in a sec. Okay, so on here I haven't got a setup and a loop. I told you that last time. I've just got an int main. So the main function is what all C programs have, and they return an int, just in case you're running this either from another program or the command line. Right, I think that's 5 beeps you heard there. Eventually this will go into a continuous beep, because it means the door has been left open for so long now that can't possibly be you putting your shopping away. Something else is happening now. You've left it open. Now in the original functionality, the one that's currently fitted, it actually fires up a different beeper at that point, because this one's loud enough for me to hear here and you to hear presumably, but it actually sets off a much louder alarm that you can hear right through the house. I mean, not ear splitting, it's not like a fire bell. Yeah, we can hear it, but it's not that loud. So on this one, I haven't been able to do that. There are no pins left, but a little bit more on that later. Okay, let's whiz through here. The main then returns the value to whatever's calling it, because in an Arduino environment, an embedded environment like this, it has no effect, this int at all. There's nowhere to send it back to. Okay, now you notice I've got this if-def debug, because I defined a debug right at the top. That was an attempt to me to keep the cost of the code down so I could remove the debugging. As it happens, I didn't need to do that. So we'll just carry on. Oh yes, I am using the method of setting pins low, high, direction, you know, input, output, the C++ way, sort of. These have all been defined, like DDRB, they've all been defined by Arduino at sort of the next level down. You can have a look in your core programs, the Arduino AVR hardware. There's a pins.h, or it might be variant.h in this case. Oh, I think that might have been the final warning. I don't know. We'll see. So they've all been defined in there, but I'm still using them because it does save a little bit of memory. So I've done that all around here. Right, moving on then. This is the timer for the tone that you're hearing. That's becoming increasingly annoying. I'll switch it off in a minute. Yeah, I've got the Watchdog timer enabled so that if something did happen to this, which is what happens to the one I've got now. Ah, there we are. That's the now insistent alarm. You see the output here has changed to alarm from warm, and that will just continue forever. And I'm thinking, do you know what? First of all, let's shut that fridge door. Oh, thank goodness. I'm thinking that might be loud enough, actually. I've tried putting a little tube over that piezo sounder there. So like a little toilet roll, something like that, or even a better kitchen roll tube, so it's a little bit narrower, and it does increase the volume appreciably. So I'm thinking, would I get away with one alarm? But as I said, more on that a little bit later. So back to the code. I'm saying, yeah, this bit here, I've got the Watchdog set up because the one inside at the moment, occasionally, every few months, hangs. So you open the door, nothing, silence. You think, hang on, did I press something? No. Why not? And it's literally hung, nothing, it doesn't work. So I have to reset it, lean right over the top, press the reset button, it's quite a stretch, and then it springs into life, and I go, what made it hang? Was it, there was a little glitch on the voltage? What? It can't be anything to do with the code. It can't run for months and months with the door opening of that fridge, you know, 20, 30 times a day, some kind of memory leak or anything like that. Not a chance. So I don't know what makes it hang, but I should have put the Watchdog timer code in there. And that's exactly where this whole project idea has come from, really, because I was going to put the Watchdog timer code in there. It's only a couple of lines, just so that if anything stops, the Watchdog timer springs into life after, say, 8 seconds, the longest I can put it for, and goes, right, reboot. And then it'll do it for me at 3 o'clock in the morning or something, and I'll never know it's crashed. So anyway, I've put it on in this one here anyway. There's the Watchdog timer enable. I've set it for 8 seconds. Yeah, why not? I mean, I don't want it for, you know, 64 milliseconds or something, do I? Might as well give it a chance. And this here, this while one, is just a continuous loop. Funny enough, Arduino and loads of other people don't do while one. We discussed this in a previous video sometime. They do for, open brackets, semicolon, semicolon, close brackets, squiggly bracket. It compiles down to the same, doesn't make any difference, but I just like the while one. It's a little bit more descriptive, isn't it? While one means one is true. Well, while one is true all the time, isn't it? So therefore it would just be a loop. Okay, so that's the loop. There we are. Look, there's my Watchdog Reset, and I think I'll do it a couple of other times. Anyway, I'm going to let you look through this because it's just loops. Like, is the door open? Yes, it is. Well, let's start a timer going, and after 60 seconds, start beeping. And if after 5 minutes or 10 bleeps or whatever I've coded in here now, I can't remember, it then just says bleep forever. I think it's here, this bit here, look. So we've come out of this loop for the individual bleeps, and it says, oh, something's gone terribly wrong now. I'm just going to continue beeping in this loop forever until you do something. Okay, now the door status, which I have to read all the time, of course, I have to poll that now for reasons I'll explain in just 2 seconds. That code, the door status code, actually calls the WDT reset. Okay, so the Watchdog timer is being reset every time I check the door, because that's the most frequent thing we're doing. So it's an obvious place to put that code. Okay, so I don't have to do the WDT reset really anywhere else apart from the very top of the loop. Right, now why do I have to keep continually polling for that door? I don't do that in the original code, and the reason I don't is because I've got an interrupt on that door. So as the door opens, or closes in fact, there's an interrupt, and that interrupt then is obviously serviced by an ISR, interrupt service routine. And the main loop then says, oh, something's changed, I'll carry on. And it can detect that change even if it's embedded in an inner loop. So you've got the main loop and you've got an inner loop going around, like beeping, for example. And it says, I'm just going to continue going around this middle loop until the door shuts. Well, of course, the door shuts, the interrupt is triggered, sets a variable. This can then detect that that variable has been changed. But here, I cannot do the interrupt. It took too much code. Now, since I had that issue, I have reduced the code yet again down a bit. It might squeeze in, but it was so tight when I did that interrupt, I thought I'm not even going to continue doing that. I wasted, an hour trying to figure out a way of doing an interrupt with the ATTiny13, and with all this other code I've got on here, it wasn't going to work. And I thought, okay, I'm just looking for functionality here, aren't I? I've just got to detect when that door's open or closed. So the fact I've got to make frequent calls now to that routine, door status, well, so be it, really. The only tiny downside, and it will happen eventually if I was to use this, imagine that you're in the middle of a beep, like we just had for about, say we're on the 5 bleep time, right? So the door's open, it's been open now for 5 lots of 30, so it's bleeping 5 times. If in the middle of that you shut the door, nothing will happen. It will continue that series of 5 beeps. Then it will discover that the door's shut and give you the door shut sound. The original one I've got there, because it's got an interrupt, as it's doing the 5 beeps, it does 1, 2, 3. Oh, door shut. Kill that. Stop. Door closed down. Finished. It's just a little bit slicker and it's more immediate, isn't it? I can't do that here. We could argue that I haven't then replicated exactly the functionality because I haven't got that interrupt working. But, well, that's where it is. You'd have to decide yourself whether or not that is a killer or not. I must admit, I'm a little bit disappointed I couldn't get the interrupt working. When I say couldn't get it working, I mean there wasn't enough space to code it. But as soon as I did that attach interrupt, either manually like that or with the C++ calls and then defining the ISR, it just went bananas. Far more code there than I ever would have expected for that. So that's just one of those things. You can decide whether or not that's a deal breaker or not. Whizzing through then, okay, here it's reading the touchpad, and that's it. So that's all the rest is the door open, the bleeps and everything else. Great, that's it. Code finished. Apart from, as I say, the interrupt not working. Right, one thing I haven't shown you is what it compiles down to. So let's hit the compile button over here and see what that compiles down to. Right, that says 796 bytes of code itself, 28 bytes for data, and then another 2 bytes for uninitialized variables. So there are somewhere in here, there's 2 variables that I haven't set a value to, so it reserves space for that. So 30 bytes for data, 796 for code. I think that's actually amazing. It did shrink down quite a bit when I did a few tweaks and whatnots in here, but even so, 796 bytes, I mean, that is fantastic. If I put exactly the same code into the Arduino IDE, let's see what that does. So here we are on the Arduino IDE now. Let's press the compile button on here and see what happens. It gives it slightly easier to understand, I think, isn't it, from the Arduino IDE. This is compiling everything, including all the libraries now, because I haven't done this for a little while. Here we are. So it says here 814 bytes with 30 bytes for memory. So it's just a few bytes more in the Arduino IDE. I don't know why, we're talking 16 bytes, aren't we? But even so, there's loads more space left. So look, out of 1024, you're using 814, and we got 34 bytes left, a whopping 34 bytes left for variables. Yeehaw! And there's just one final thing. You remember I said about the loud beeper I have on the existing one? Well, because this has got a light on it, and because this is wired up sort of incorrectly for this circuit, it shouldn't be the light on all the time. The light should be off, and when you approach it, instead of the light going off, I want the light going on. So then why have I got this extra light on over here? Yeah, I know it's telling me the state of the sound, i.e. there will be no sound next time. Door open, door close. But I don't really need that. I could remove that functionality, this LED, and use that for the really loud beeper. So I think, okay, it's pretty much what I've got, or could be made into pretty much what I've got. Not quite as slick because there's not that interrupt, but would this actually work as I say, a commercial fridge door alarm? If some big company said, right, we want to put in a door alarm and we don't want to use the internal light because that's not really effective enough, it's just not reliable enough. Could we fit something like this with an ATTiny13A rather than a bigger chip that costs more money? And the answer is absolutely. This would be, you know, you could probably build all this, the beeper, the board, the chips. If you're talking, you know, 10,000 plus chips and all that, you could probably fit the whole thing for about £1, I reckon. So $1.30, €1.30, something like that. I reckon you could do it for that. PCBs, you know, you can get 10,000 PCBs. And believe me, when I say 10,000, I know to us hobbyists that sounds like, ooh, huge amount. No. Now, I have a friend who's an electronics engineer, proper one, not like me. He does this sort of stuff for a living, you know, builds big things. And he used to go to China and to get quotes for PCBs and stuff, and they think they were building 10,000. I can't remember if it's now it is per year or per month. But the PCB factories in China go, no, sorry, that's too small for us. We wouldn't do that. If you're talking 100,000, we might consider it, and we're really looking at 1 million. So you can just see how big business PCB production in China is. So the fact we're using, in this case, PCBWay, great place to get your PCBs from, and I've never had a problem with them. The fact they're offering them to us hobbyists is absolutely a godsend. If they all turned around and said, no, you've got to order 100,000 at a time, well, it would be totally outside of our remit, wouldn't it, to be able to order anything like that. So, yeah, well, that's just a little aside. So I reckon this is good enough for a commercial door alarm, fridge door alarm, definitely. The one I've got inside is well over the top. That wouldn't be considered viable as a commercial one because it uses this nano. And even if you built your own nano, as I did for my toothbrush time, you remember that little plug-in nano replacement? You just don't need a chip that big with all the pins. I mean, most of the pins on that nano are unused. And yes, whilst I have an extra pin for the extra loud timer and things like that, the only thing really missing on this one is the extra loud alarm. But either the manufacturer would say, look, we'll just investigate a couple more of these pizza ones, see if we can get it bigger, or build a little 3D plastic thing that goes on the top to make it quicker. Well, louder rather, not quicker. Well, it might make it quicker as well, who knows. But it would make it louder. It's enough, frankly. Yeah, I reckon that's pretty good. So, the verdict on this, you can make your own ones up, but compared to the one I've got currently in my kitchen, that direction, and this one, I would say this is a pass. Definitely. The ATTiny13 is not brain dead. Official. It can do much more than I ever envisaged it could do. The only thing it couldn't do in this case was the interrupt, because I just ran out of space. Perhaps with a little bit more tweaking I could just squeeze that in, but even so, I don't think a manufacturer of fridges would think, oh, we couldn't fit that interrupt in there, we'll have to get a bigger chip. Not a chance. They'd just leave it like this, exactly the same, wouldn't they? No different at all. So there we are. Great. That's all I've got to say about the ATTiny13 fridge alarm. If you want to build one, I'll put the schematic up, the PCB you've already seen, but I'll put the design of that up there. The code, of course. Don't forget you're going to use the ATTiny core from NC Dude. I'll put all that up there because this is a nice little beginner's project, frankly. Well, in fact, the one I've got built back there, I told you last time, it started off as a 555 timer. It then went to a PIC something or other, 12F something. Then it went to a Nano. It's been like that way for donkey's years. So I think that's probably about it. Let's have a quick... Oh, yes. Now, this is interesting. I was looking around for a little project box or something, and I saw this, and I thought, that's one of my beeper boxes. It was sort of an extension beeper box. Now, the interesting thing is, inside... Let me just take off the lid with my... This is my new electric screwdriver from Banggood, by the way. I paid for this on their Good Friday thing. It's still quite expensive, I thought, even on a Good Friday, or Black Friday price, but it's nice. Anyway, let me just whip these off. I can't really see what I'm doing, to be quite honest. At least it gets these screws out. They push it really for like laptop use, you know, all those little tiny screws. Anyway, what I found in here, see, look, 2 beepers. One pretty much like the one on the workbench behind us, that little tiny one, and then this big whopping, well, buzzer, I think you'd call it. Oh, if you're interested in this screwdriver, I think it's called a Wow stick or something like that. As I say, it was expensive even with the Black Friday price. For me, I thought, I don't know, is it? But I saw the reviews and everybody said how wonderful it was. And I'm quite pleased with it, I must admit. It does all these little tiny electronic screws. Don't start putting your flat pack IKEA furniture together with it or anything like that. No. This is for little tiny laptop screws, you know, the battery screw mounts and all this kind of stuff. So yeah, I'll put a link in case you're interested. Right, that's it for this week. I hope you've enjoyed it. Pretty quick, but that ATTiny13 really does seem to be worthwhile. Moving to the ATTiny85 afterwards though was like, oh, I'm free to do stuff. I don't have to worry about the code. So yeah, the ATTiny13 has its place. Let's not be silly about it and try and cram too much code in there. Horses for courses. If the ATTiny13 is not enough, then move to the ATTiny85. If that's not enough, you can go to the 84 with more pins, or of course the 328. Now in that next project, I'm going to be using not one of those. I hope to be using one of these. Now if we look at the back of this, it says, upside down, it says LGT8F328P. Remember we went through that. This is like the supercharged 328 from Logic Green. That's the LG bit. But this is the mini evaluation board, EVB. So really a Pro Micro, I guess. So I'm going to try and use that. If it fails, my fallback position is in fact a Pro Micro. This is going to cope with anything I throw at it for that little tiny project. It's a very little simple thing. So we'll see how that works as well in the future. Lots of things coming up then. If you want to subscribe, don't forget to watch the bit at the end and just click on my picture. Comments down below. Love listening to you. Don't forget to give it a thumbs up. Tell YouTube that this was worthwhile. And see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.